So in this video, we're going to do the integral of dx over square root of 1 minus 4x squared. One option is you might recognize it as an arcsin and can do it with a u sub. In this video, we're going to do it as a trig sub. And what we would do is we would let x equal 1/2 sine of theta, and thus our dx is 1/2 cosine theta d theta. Now, biggest thing that people forget with trig substitution, happens all the time, is to substitute in the dx. Part of the reason why I want to do it this way. So first thing I'll do is I'll substitute in the dx so I don't forget. 1/2 cosine of theta d theta over square root of 1 minus 4 times 1/2 sine of theta squared. Alright, so let's see what kind of simplifying we can do. So let's leave the inside alone, or the top, excuse me, alone for just right now. And on bottom, you can kind of see why we had to include that 1/2. We're going to have 1 minus 4 times 1/4, because the 1/2 is going to be squared, sine squared theta. So those will cancel, and under the radical I get 1 minus sine squared theta. That's where we use the trig identity. So we get 1/2 cosine theta d theta on top. 1 minus sine squared is cosine squared, so we're getting basically the square root of cosine squared theta. So 1/2 cosine theta d theta over cosine theta. Those cancel, and we basically get just 1/2 d theta. The antiderivative of that is 1/2 theta plus c. But don't forget, we have to substitute back. So let's go back up here. This needs to be solved for theta. In doing so, we'll multiply both sides by 2. So we get 2x equals sine theta. And then we'll use an inverse trig function to solve for theta. We get theta equals arcsin of 2x. That's that theta here, down here, excuse me. And now we can plug that in and we get 1/2 arcsin of 2x plus c, which is the same thing you would have gotten if you would have done the original with a u sub. But I want to show you, if you didn't see it as an arcsin, it can still be done with a trig sub. You get to the same answer.